Thank you.
Thank you.
Thank you very much.
Okay.
It's actually a continuation of my previous presentation. Right now we are again it's a cooperative work of Helmholtz-Zentrum at Gestalt and together with the National Technical University of Athens. And in this presentation I will show you the results, newly investigated results on aluminum, copper, lithium alloys 2198. I will motivate myself. First of all, right now here you can see this is the Airbus A380. Here you can see aluminum lithium alloys are mainly used of the main door floor beams, and there is a possibility also to replace 2024 at several structures of the aircraft. So we have a very strong motivation to check about this new alloy, aluminum lithium alloy, and to see its corrosion potential in order to be used in such aircraft structure. I will motivate again myself. Still, we haven't found a single article on the corrosion of this kind of alloy, and I will show you some preliminary results. Again, I'm saying you have all seen this. Sorry about this. Now we have reduplicated all the same work with 2198, and we also made another comparison. So we have masked these areas, and in another test series we also masked the thickness of the specimens, because we have noticed that large corrosion cracks are initiated just like blisters are coming from this thickness. So we have actually two different cases. The one that we have corroded all four specimens of the tensile, all surfaces, all four surfaces of the specimen, and another one is, we call it covered, so we have just covered the top and bottom surface. Here I think we have done the same work with artificial aging, but I don't want to stick on the artificial aging because it's too early to speak about this. And we have used the typical tensile specimen and fracture toughness specimens, and I'm not quite sure. We have also here we have covered all the surfaces here, except we have left these surfaces just for cracks to grow. So only these surfaces, small surface, was corroded. Now here you can see still these results are unpublished. Here you can see this is 2198 with different exposure times. So you can see after 2 hours you have only decrease in ductility, not in strength, and excessive exfoliation leads again not to essentially decrease yield stress, but only ductility. Here you can see that we didn't have any stress drop. For example, as we noticed in 2024, that is really peculiar. This means we have some thoughts about cracking and hydrogen embrittlement. So here you can see the corroded surfaces. This is before EXCO. Actually in 2 hours you have no pitting at all. 24 hours you have some nucleated pits. This is of lower resolution, of course, but here you can see after 48 hours you have an excessive surface deterioration. After the tensile test, you can see that the crack path here for small exposure time is almost vertical to the applied load. This is the applied load. After 24 hours you can see that it follows the individual corrosion sites, and here it's completely destroyed. Here is the crack path. this is with the covered size, meaning that they were this is the tensile stress curves for the covered side. For comparison purposes, I will show you here the blue one is the 2 hours uncovered, and the red one is without any covering at all. So after the same was also noticed for 6 hours and for 48 hours. This means that you have a great ductility increase by simply by simply covering the side surfaces. This is a large problem because in case of riveting, you do have you are in this problem. You are exposed the thickness for here and here. The thickness of the specimen is exposed to corrosion. So this is actually a large problem. And here you can see is the yield stress over different exposure time and the elongation of fracture with blue one, and sorry, this should be the case. For example, for the yield stress, you can see that if you cover it or not, the results are also the same. So yield stress is also immune to covering or not to corrosion surface, but you do have an effect on ductility, but it's almost logical that the larger the exposure is, the larger the corrosion cracks are nucleated into the material. And here we try to reduplicate our experiments regarding the previous investigation I presented a long time ago. We saw that, for example, in 2198, you have, for example, this is the solid line is aged, and the other one is age and corrosion. Again, for the different aging conditions, here you can see that again the yield stress decrease due to corrosion is not that important. However, in 2198, it was a little bit more. But the main problem was actually in ductility, where you can see here that for all over the spectra of artificial aging, you have a decrease due to corrosion around 10% with some fluctuations, while this was not noticed for 2024. As if you were present, you can see that you had a large decrease in the very first stages of artificial aging, and at the peak aging you have a minimum decrease due to subsequent corrosion exposure. So these are all, of course, we are very happy to report this. And I don't want to stick on this slide because the gentleman is absent here. I can discuss it with him. I also report the critical decrease. Here you can see it's this line where we found something peculiar, that the maximum decrease in K critical, this is dotted line, maximum decrease is again on the underaging condition, and when you insert into the peak aging condition, then the K critical decrease is almost minimum, around 10%. This is something that we will report in the near future. Here you can see some SEM analysis. Here, for example, in this one, for 24 hours, this kind of blisters is actually evident. Of course, these blisters are due to the rolling process, and perhaps are more, let's say, sensitive to corrosion exposure. That's why we have performed all this kind of work with covering of the side surfaces. again, I don't want to stick on the conclusions, but to our understanding, 2198 seems to better in general behave when compared to 2024 in corrosion potential, as we do experience some minimum degradation in ductility, because ductility is of primary importance to aircraft structures. Thank you very much.